Okay guys, here we are thrice again. So for you it will be just the one video, but for me it's the third time recording this every bloody content again, because both the times when I recording the first time I could not merge the video, and second time I forgot to turn off the mic, so the whole video did not record my audio. Okay, so we'll start with the first topic, that is data processing instructions. So, what is data processing instructions? See, usually these four things which you have here: arithmetic, addition, subtraction; logical is that logical and or comparison, compare and negative, multiply and accumulate thing. So, but I'll see. I'm not gonna go in depth like the way I did in the last two recordings. I'll just explain you with brief so that you can just read whatever is in the textbook and understand. Okay, so moving is, see, first we have move instructions. Moving, what it does, move, it will just copy the value and replace, put it in the first place. If you have two registers, it will just assign it as equal to them. Sometimes instead of this register place, they also give this number things. Okay, and move not, what it does, whatever the thing value is, right, instead of R2 value, it will give the complement of R2 value. How I had explained is, suppose is 5, so 101 is 5. So if I take complement of it 0 1 0, so the value becomes 2. It's just like that. Barrel shift. So just read this. Okay, I'm not going to read again. I will just explain what happens here. For logical left shift, suppose you have this 2 to the power of n. So whatever number you give with the LSL, this number, that value will be updated here. So logical left shift is like multiplication. Logical shift right is for division. So see, move R3 comma R1. So R3 is equals to R1 into 2 to the power of 2 is what? 4. Then same way R3 comma R1 LSR number 1. So R3 is equals to R1 divided by 2. Why it is not divided by 1? Because it's 2 to the power of 1, right? 2 to the power of 1 is 2 itself. And this 3 is same itself completely. This is just for sign. This is for unsigned. This is for signed. Okay. Then you have this now arithmetic operations. Addition with carry. See, it just adds this two value. In with carry, this adds this two value with a carry. Subtraction, R1 minus R2. Subtraction with carry, R1 minus R2 minus C. So reverse subtraction is nothing but, see here, I'll explain from here. This is R1 minus R2. Reverse subtraction, R2 minus R1 will happen. Here at this specific place, it's like hashtag 0. So it's nothing but 0 minus R1. R0 is equals to 0 minus R1. So 0 is nothing, right? So it's basically minus R1 itself. Understood? Then you also have reverse subtract with carry. So you will have minus C for reverse subtract. That's it. Then you have comparison, that is, I'll go directly to here. Comparison is nothing but equivalence. Sometimes it is subtraction if only two registers are given, else it is this. Updates the CPSR based on R1 minus R2. Comparison negative is just addition based on R1 plus it updates the CPSR. So basically understand that comparison instructions deals with updating the CPSR. Test bits is nothing but updates the CPSR based on R1 and R2. Test equality based on R1 inclusive R2. It's basically this symbol. What is that? Triangle type. Okay. Logical. See, and or exclusive or, instead of this you can also use this cap symbol, and this bit clear. This just understand basic multiplication or and or basic logical operations. And coming to multiply instructions, see, multiply is just basic multiply. In accumulate, what do you have? You have three values. So you multiply the first two values and then add the third value. See here, multiplying the first two values and adding the third value. So you have R0 comma R1 comma R2 comma R3. R0 is equals to R1 into R2 plus R3. Okay. Long multiplication. So you have unsigned multiply long, unsigned multiply accumulate long. So in long only multiplication, here you have to add. Sign, both are same, just instead of unsigned you will be using sign. What is happening here? R1 comma R0 R1 R2 R3. So first two ratio is happening, second two multiplication is happening. In unsigned, instead of equals you have a plus and equal, that's it. Okay, nothing else is changing. Branching is nothing but, branch is like there is a flow of instruction. Once the instruction is completed, you will move on to the second instruction, right? But in branch, what happens? Some other things are added in the middle. So for that to execute or complete, you need some other instructions to be what to say, executed. So that's why branch comes, where it updates the program counter PC to a new address. So that new address is of some other instruction that will be loaded. Branch with link, same thing as branching, but I'll just show you over here. See, same thing as branching, but it returns the address to the link register. L is nothing but LR we are using over here. Link register, the address is returned to this. Branch exchange, so you have this RM, source register. So absolute address is, it branches to the absolute, branches to this. Okay, that's it, and updates the T. T is updated in CPSR. Branch is also dealing with updating branch with link and exchange. Both the things are happening. It will branch absolute address and then it will return the address to link register. That's it. How branch only B is used. Forward branch and backward branch. In forward branch, it skips the instructions, goes to the other instructions. So see, if you give this forward, it's not skipped and gone to that subtraction. Backward, you give this B bracket, creates an infinite loop. That's it. Subroutine call, it's just like you're just entering the subroutine mode. If you have to exit the subroutine mode, you have to return the link register to PC. So if you see here, branch with link stores the return address in LR, allowing function calls. Returning from a subroutine is done by moving LR to PC. So basically, this subroutine is nothing but, see, this function calls. If I put it like this, okay, compare R1. So it's, see here, R1 equivalent to 5 subroutine. Then if you have to come out of this subroutine, function call, return the LR to PC. Branch with exchange, see, branching into or from thumb mode. Okay, remember, BLX works as same as BX, but it also returns the address to LR. That's it. Now we are going to talk about load store. Load store we will talk in the next lecture, because that deals with program instructions. Okay, so we'll start with that. Bye bye. See you in the next video.